Cool. So today I'm Arneaud, as you can see up there. So I'm just I'm a little consultancy here in Sydney. Just with myself. And yeah, I'm going to talk about databases. So let's go straight. So yeah, I want to say something up front of first. So first off, yeah, relational databases do have a learning curve. So if you want to learn how to use relational databases well, you actually got to sit down and study them and actually learn how to use them. It's not like some other things that you pick up. It's more like Python as a language or pandas as a database. I think you actually learn how to use it a bit. But they're actually really, really useful. So a lot of commercial applications are basically just a nice user interface around a database. So you can really use them for a lot of stuff. And I hope by the end of the talk you kind of appreciate some of the things you can use it for. So I think if you say learn Python or learn some tooling, looking for a new tool to learn, I think anything to do with database is some of the most practical thing you can learn trying to teach yourself something. So, and yeah, relational databases can be useful for a lot of things, but you also find there's a lot of other tools that, for a specific problem you've got, you find another tool that's more specialized and does a better job for it. For example, Elasticsearch, which I'll mention later, is a really good tool for doing search. But relational database is often good enough. And it's often like one tool that's good enough for solving most of the problems. So if you've got an application with lots of problems, instead of having a tool to solve that problem, a tool to solve that problem, a tool to solve that one, you can have a really good, solid, trustworthy general purpose tool that you can just use instead of maintaining all those other tools. And yeah, there's been a lot of talk in the past, especially in the last decade or so, about how relational databases don't scale that much and not web scale. Yeah, I have actually worked with applications that aren't too big to fit on a relational database. But the overwhelming majority of applications I've worked on in my career fit just fine on a relational database. So an example, so this is not something I've worked on, but it's something I'm sure most of you would have heard of, Stack Exchange Network. So apparently, the Stack Exchange Network runs on 4 SQL Server instances. So 2 of them are apparently for Stack Overflow site, and the other 2 for the rest of the site. And I actually think the main reason why they have 2 on each is most for redundancy. So they want to be able to take one of the servers offline for maintenance and upgrades and not take the whole site down. So they always want to have at least 2 instances. So use that for a bit of perspective. If you think Stack Exchange is a pretty big site, doing a lot of cool stuff, and yeah, they're just running their stuff on relational databases. So yeah, that's partly because current year is 2017. So if you take a look, you can get some pretty awesome hardware pretty easily. So I remember in the noughts trying to fit stuff onto VPSs with less than 100 megabytes of RAM. Nowadays, the smallest machine you can get from AWS, they call it the Nano. It's half a gigabyte of RAM on that thing. It's really like a luxury world right now. And I'm measuring here at the bottom, 90,000 seconds in a day. So it's worth just doing some back of the envelope calculations sometimes. So sometimes I get people saying stuff like, this product has to serve 100 teams of people. Are you sure it can take the load? Do some quick calculations. Yeah, be fine. Don't even break a sweat. So do some back of the envelope calculations. You often find that even quite powerful and useful apps can fit just fine on quite simple hardware these days. So this is, a quick look at what relational database looks like, if you haven't seen one before. So we've got 2 tables, a comment table and a user table. So these are a bit like classes in Python. So a comment class and a user class. And I'm not sure if you can see that, but you probably can't. Any? So we've got each column here is like a member variable of a class, and each row is like an instance of the class. So this comment, a title and a comment and stuff like that. And you also see we've got these IDs and this author ID. And that's used for foreign key relations, for linking things together, or joins or something called. So here we've got the user with ID 0. It's joined to 3 comments here. So the user with ID 0 is the author of 3 comments. This is what it looks like when you're programming. So this is SQL. Now if you switch a bit, this is creating a table. It looks vaguely like creating a class in Python, but you've got the name of the thing and then we've got all the members, if you like, and columns. This is inserting data into the table, and this is going to pull stuff out. So bit ugly, but that's what it looks like. This is what you're doing most of the time when you're working with SQL. But you can do things that are a lot more complicated. So you can do like arbitrary mathematical operations and stuff like that. And here we're using a join, so we're using the relationship between comments and users to pull out all the comments that were authored by Simon. So that's using a join. And here you're inserting some data. But here, making a point that you can actually nest things. Just like you can nest mathematical operations by using brackets, you can nest queries inside other queries. So here we're nesting a get or a select into an insert, which is like a put. But yeah, that's pretty clunky. So I'm pointing out that SQL Alchemy is a library, and I can use Python that lets you write Python code that generates all the SQL stuff in the background. And Chong's giving the next talk. He's going to talk about another way to do this. So just because you're using relational databases, doesn't mean you have to use this clunky SQL language. It's a powerful language. It's clunky. You can use it. It's good. But if you really don't like SQL, and it's like the main reason why you don't want to use a relational database, you're not forced to use it. So yeah, let's look at some of the databases we've got. So I'm mostly going to talk about these three because they're the ones I have like hands-on experience with. So MariaDB, I'm going to practice there, it's actually a fork of MySQL. So MySQL is an old database, got bought out by Oracle. A lot of people don't trust Oracle, so they forked MySQL to make MariaDB. So it's basically the same thing, it's compatible, but run by different people. Firebird is another free database. I played around with it a bit. It doesn't feel as mature as the other ones, so I'm not really going to talk about it too much. And then a bunch of these proprietary ones. These two at the bottom, IBM, DB2, and Oracle. They have really quite complicated and expensive licensing. Also, you mostly see these in big enterprise. Microsoft SQL Server is apparently a pretty good one of those four. I think these two, they're expensive, but I'm actually convinced, especially with Oracle, that they're actually that worth them. Really getting value for money with them. But Microsoft SQL Server is apparently pretty good. But yeah, so I'm mostly going to talk about the first three because I've got most experience with them. So yeah, you might be thinking, a lot of databases to choose from. I know I'll just write database agnostic code so that I don't have to choose a database and just figure that out later. Unfortunately, there isn't really any such thing because each database is just incompatible enough that you basically don't have to choose a database up front. So I will talk a little bit about some of the major databases to help you make that choice. So MySQL. So historically, it's been really, really popular. It's the M in LAMP stack, which was like all the rage for web development in the noughts. Also, it's a reputation for being really fast and really easy to use. If you look at really big deployments of relational databases, you'll find that tend to be MySQL deployments. So, for example, kind of ironic, fun fact, AWS's DynamoDB, that's their big NoSQL offering. That's actually a layer on top of MySQL. Another example, Wikipedia. They use a lot of MySQL in their backends. So Facebook, yeah? Okay, I do know that one. Doesn't surprise me that much. Yeah. You will notice that a lot of the big deployments, they tend to be using MySQL rather than other things. But you notice that there's a big but at the end of it because I actually really don't like MySQL that much overall. Apart from it is pretty good for cluster stuff. It's pretty bad for everything else. So the performance. So originally it got a reputation for being really fast, and that's mostly because the original database backend they had didn't do stuff like integrity checks and stuff like that. So you could easily corrupt and lose your data when you're using it. And that gave them a bit of a bad rap. So they started adding backends with more integrity checks, and that slowed things down a bit. So MySQL got slower. And then the other databases like Postgres, they actually got faster. So I think people do benchmarks, so you can always see benchmark walls everywhere. But I think these days performance isn't so clear-cut as a reason to be using MySQL as it was, say, 15 years ago. Also, the easy-to-use thing. With MySQL, if you tell it to do something, if you make a mistake when you're using it, MySQL tend not to give you a warning or error. It will just silently do something you don't want to do. That tends to be the philosophy with how MySQL works. So I actually think that Microsoft is really hard to use because you have to read all the documentation really carefully to make sure not to shoot yourself in the foot. The query planner. So the cool thing about databases is that you just talk about what kind of data you want, and the database figures out how to get that data. That's what the query planner. So all the databases have these, and MySQL isn't that bad for simple queries, but it's actually pretty stupid, and it's really easy to confuse it. So you can write a query that works, and you tweak it slightly, and then it's completely goes out of whack. So one example, I once had a query that worked fine on view, it was good, and then I added one constant value to the end of it. So just, please, MySQL just take the results of this query and add a single constant value as a row at the end. That completely threw it out of whack. Like it went from being an efficient query to just, oh god, I don't know how to do this. I'm just going to just look at it. It totally screwed up. Sorry? It was a union of a view with a constant. It's like, why the hell was that hard? But yeah, it was too hard for it. Yeah, so basically, multi-master deployment is the main advantage that MySQL has got over other things, but generally it plays feature catch up with basically any other database, including SQLite, which I'll talk about later. So I could rant all day about why I don't like MySQL much, but there's someone else who's done that for me. So check out this if you're not convinced from what I said already. There are so many things that are obnoxious about this database. Postgres, I'm not going to say too much about this because it's generally pretty good. It's a lot of this is an industry where we like shiny, cool things. Postgres isn't really that shiny or pretty or anything. It's just very straightforward and standard and reliable. If you tell it to do something, generally it will either do what you want it to do or it will give you an error. And I kind of like that. I like a database that I can trust in that kind of way. Also, the feature set is actually really, really impressive. I feel like every time I use Postgres for a project, I learn some new, actually really useful feature that I didn't know I had before. It really is pretty good. Also, one of the examples of good features it's got is the authentication options. So I think MySQL, as far as I know, I think it only supports basic username and password authentication. But Postgres has got a really highly configurable range of options you can do to integrate with things, which when you're using a database for longer term, it actually helps reduce day-to-day sort of maintenance work to do with this integrated stuff. One thing I think, I'm going to give a negative, I think installation is a bit of a learning speed bump. So once you know how to install and set up Postgres, it's actually not that hard. But if you're new to this stuff, you just want to try things out, it is a bit of a speed bump, I'm going to say that. SQLite. So SQLite is pretty cool. So we're mostly talking about servers, like you set up a server and then sending queries over a network. SQLite is different, it's just a library. And it's actually on bindings for it. I think I should put it into Python. You can just import SQLite bindings. And it just creates a database as a file. So creating a database is just as easy as creating a file with SQLite. So it's really easy to install and deploy. As an example, Firefox. So Firefox actually embeds SQLite. It uses SQLite for things like cookies and caching and some configuration as well. So the example of how easy it is to install, most people who install Firefox have no idea they're actually installing a database because it's just inside the application. So a really cool thing about SQLite is that you can use it with the full power of a database, pretty much, without having to worry about installing stuff. So you can use it in places where you wouldn't normally think of installing a database. And it's really good for learning stuff. So if you want to have a database server to play around with, this sort of thing. So these databases tend to have REPLs. The cool thing about SQLite is that you can just type in, like in Python, just type in the name of the REPL and it loads up the query. You can start typing things in. So normally you'd have to set up a database with users and login and stuff like that. With SQLite, you just get into the REPL and you've got an in-memory database you can use straight away. So it's good if you just want to play around with SQL and relational database stuff. One thing I really don't like about SQLite, it's really loose with types. It doesn't have any strong typing. So, for example, with Postgres, if you've got a column that you declare to be an integer column, and you stuff up your code, you try to insert a string into it, Postgres will just give you an error. MySQL and SQLite will instead try to come up with some random way to convert the string into an integer, probably come up with total nonsense and insert it anyway, just corruptly done it. I don't really like that feature of it. I think they actually got code to implement this feature, and I think it's just not a good feature at all. Also, yeah, it's pretty good overall. It supports SQL generally, but there are a couple of things that are documented that it doesn't actually support. But generally, don't come across it as doing more complicated stuff. Overall, it's like when I first heard about SQLite, I actually was just some toy thing, just basic SQL features. It actually has a lot of features. I think actually overall it has more features than MySQL even, so it is worth checking out. I won't go too much into this, but worth knowing if you're using SQLite, there are two main modes to use it in. There's one I like to call Big Fat Lock mode. That's if you're doing a lot of reading. So with Big Fat Lock mode, as I call it, or Robot Journal mode is officially known, you can have lots of users reading from the database But as soon as anyone wants to write to it, the whole database gets wrapped up in a big fat lump. No one can use it except for the writer until they're finished. So obviously that's good if you're reading a lot, but if you're doing a lot of writing, that's not good performance. There's another mode, slightly more complicated to use. That's you're going to read the fine print a little bit, but it's called the write-ahead log mode, and that is much better than write-heavy stuff. So you can actually use SQLite for write-heavy stuff. I'm mentioning this mostly because a lot of people have only heard about this mode, and they think that SQLite is only good if you're doing lots of reading. It's bad performance for writing. But if you change the settings, you can use it in write-heavy applications as well. Yeah, so that's the main part of the talk. What can you actually use databases for? So basically what you use it is, using it the original way Cod intended. So Cod is the guy who was around about 1970, he was a mathematician, figured out the mathematical theory of this relational database stuff, which is, or had the diagram of two tables, splitting the data into two tables with joins on them. That's basically the whole normalization thing. So they came up with a whole bunch of normalization rules, which are, I think, worth learning if you are interested in this stuff. There's a popular myth out there that what Cod said about normalization is, kind of nice in theory, but a bit ivory towerish, and that if you really want real performance in a real database, you've got to move away from that and denormalize stuff. Actually, in a lot of cases in practice, people screw up their performance trying to denormalize their databases. So be careful. I think as a default, it's worth sticking with normalization and then only denormalizing if you actually measure and feel like you need to. But yeah, that's a, I suppose, proper way to use a database, but yeah, much more things you can do. So yeah, you can use it as a key value store. So typically we just have a table with a key column and a value column, and you can stick things into that. So that's a really strange way to use the database. It's actually really useful if you're migrating data from an application that wasn't originally made for a relational database. So you take your data, you migrate it into a database like this, and then straight away you've got all the features of a relational database, so you can add more columns. If, for example, a typical key value store will let you do lookups on the key, but once it's in the relational database, you can add an index on the column, an index on the value, and start doing lookups on value as well. You can add another column, or add a new table. With all the flexibility straight away. And yeah, document store. So the whole NoSQL thing that was really big, that's the end of the last decade. I was basically about the idea that this relational stuff is not so great. What we need to do is put our data into JSON documents and put those documents into a document database like MongoDB. Now, ironically, people did some benchmarks and found that all these databases have really good native support for JSON stuff. MySQL. It does have support, but not so good. But these all have really good native support for this stuff. It turns out people did benchmarks and found that it's actually faster just shoving JSON into these existing battle-hardened databases than trying to put into new stuff like MongoDB. So there's irony there as well. Text search. So in practice, it tends to be like 3 ways that people implement text search functionality in their application. So one that a lot of people think of first, and a lot of people never think of any alternatives, is something like Elasticsearch. So Elasticsearch is a standalone server. It just runs, you can set it up, it runs. You feed documents into it, it creates an index, and then you can send search queries to it. That's a lot of good features, pretty cool. A second option, one I think is underrated, is to use a library. So one that's good for Python, should I pronounce it exactly? It's actually a C++ library, but it has Python bindings, so really good. So this one is not a server. You just import the library into your application, and then it creates a file for the search index. So that's neat because you still have to manage your search index, but you don't have to manage the server anymore. So that's less stuff to manage. And that's pretty good features too. Third option, if your data is already in a database, you can just use the database. And now you don't have to manage an actual server. You also don't have to manage the search index. So about a year ago, I was working on a project that originally had data in Postgres and was also using Elasticsearch for search for documents. And what was happening was that every time they put stuff in the database, they also have to replicate the stuff to the Elasticsearch instance. And as scripts for that, it was working okay, but the two would keep on going out of sync. It was actually turning into a bit of a maintenance task to keep these things in sync, the database in sync with the search index. So what we ended up doing was we threw away Elasticsearch and started using Postgres built-in text search functionality. This meant there was there's only one source of data. There's nothing to sync up anymore. So it actually reduced the maintenance load quite a lot. So that's a year ago, and haven't looked back, still using that, and things are winning. So Postgres.
Was it fast enough?
Sorry?
Was it fast enough?
Oh yeah, I mean, it's got indexes for it and stuff. It's sort of more functionality built in.
Does it have like reverse indexes?
Yeah, well, so Postgres, it's got full text. I don't know what they call them now, but yeah, there's indexes based on words and stuff like that. So
Trigram index.
it has that, but that's not what I'm going to think of. It has trigrams, but it's another one's a generic index, which was there's a few different index, actually 3 different index types for text search. You take a pick, but you just pick one that works pretty well. It supports stemming, stop words, language enough to have synonyms or dictionaries. It's ranking. It's highlighting snippets. It's built in there as well. It's actually got quite a lot of functionalities. You have to. There's a bit of assembly required, but it does have the stuff. It can build a search engine that's probably good enough for most situations. So it's worth considering. Another one, geographic information systems. So this is like if you've got a database with all the post offices in Australia, you want to find the nearest post office to the user at any time, something like that. So usually this is using extensions to the database. But yeah, all the major databases have really good support for this sort of stuff. We can do geographic information queries as well. Message queues. So yeah, a lot of applications, you do something like RabbitMQ for this sort of thing. So let's say if you've got some process that's generating messages or events that fit into a queue, and you've got some other process that's reading off these events or messages and doing some sort of processing on them. So yeah, you can use something like RabbitMQ, which is very efficient for this sort of thing. Relational databases aren't as efficient, but if you're processing like under 100,000 or even a million messages a day, relational database is probably fine. And so people have been using databases for this sort of stuff for a long time, but since 2016, Postgres implemented a new feature called skip log. I won't go into the technical details, but it lets you implement queues in Postgres a lot more efficiently than it could before. Actually, just read today, MySQL announced that the next version of MySQL is going to support this as well. So they're catching up. PubSub. Yeah, so I mentioned this in passing, it's not that great for performance, it's not very scalable at all, but it does have it. So you can use a message broker, or if you've only got like a handful of things that need to subscribe to messages, maybe you can just do it with a database and you don't have to manage it on the server. The file system. So some people might think this is a bit strange, but yeah, people say you don't put big blobs of data in your database. That's bad practices. It's a good thing to do. But even if you think about performance, it might actually be better for performance to put blobs in a database. So little files on a file system aren't actually that efficient. It's not very good for performance. So SQLite, they did some testing. Microsoft, they did a really good paper. They did some benchmarks on a whole bunch of different blob sizes and stuff like that, and they figured that in many cases it's actually better performance to put blobs of data in the database than to put them in the file system. So really broad rule. If you're looking at stuff that's less than about a megabyte or something like that, it's probably more better performance to put it in the database. And even if you're looking at stuff that's bigger than that, it might not be the ultimate best performance, but like what I was saying before with the search, if you can have all your data in one place, then you don't have to keep it in sync with the file system. And that could actually bring architectural benefits to your application. So it is worth considering, even if not much bigger blobs. Maybe it's good enough just to stick with the file, in particular with the database. So that's actually all I've got. I hope I made the point that you can actually do a lot with the database. So in my consulting work, I often come across people who they have a problem straight away. They want to install some server like Elasticsearch or something like that, and then pretty soon they've got an architecture with loads of servers that they've got to manage and it falls down. But if you know how to use a relational database, you can often just use a relational database and get a much simpler, much more maintainable architecture. Any questions?
About your blobs at the
So some people are concerned about fragmentation and stuff like that, various technical things like that. I don't think there's been much change in the database side of it. File systems have definitely changed in the past 20 years a lot. But so that Microsoft thing is actually 10 years ago, so things have changed a bit since then. So I'm not sure what you read. I'm not sure things have changed that much since you read it. But there are studies that people have done, so that can be a good idea.
So with stuff like SQL, most databases implement old file system underneath. MySQL has its own file system, but for SQLite, it basically has essentially a very smart pointed company system. So yeah, it doesn't actually for SQLite. There is a very good method. 35% faster than the file system. Maybe it's the way it stores.
And any of this been able to do the column-based reading rather than the row-based reading, like what Oracle or HANA is able to do? Because with column-based reading instead of row-based reading, it could access 1 million records a second.
I've heard that with Bigtable, Google's thing. I haven't heard of Oracle, so I'm not too sure about that. So,
Redshift is columnar.
Yeah.
So it's based on Postgres.
Okay.
So there clearly exists some kind of storage engines out there that stores things columnar, you know.
Is Postgres the same?
They're built on top of Postgres.
Redshift is, yes.
Yeah.
Redshift, Postgres out of the box doesn't have built-in columnar support.
Yeah. So basically, it's Postgres. Swapped out the storage engine in the background. And that's it. You can do the same way, by the way. Postgres source code is very easy to read, just like SQLite source code. My SQL source code, on the other hand, is forget it. Sorry, yeah.
yeah, if I'm allowed to keep on writing about MySQL, I like to say that MySQL is not a PHP of databases. There's a good reason why people like partnering with PHP.
It's a very good way to think about it.
Well, it's no land. That's what MMP is for.
Actually, anyone else? Questions?
That's not so bad. Yeah.
Do you have any recommendation for how to see this stuff?
Not off the top of my head, sorry. No, it's a different topic.
In terms of a backup and replication, what would you say is from your experience?
I think Postgres' backup works pretty well. MySQL's, our trap with MySQL is that often small backups will work out of the box, but then once you go to production size database, the same backup method won't work so well. So you have to tune it a bit. Not instrumental, but it's worth testing on production size databases. SQLite's also really easy to back up to. So I mean, basically they've all got good backup. You know, yeah, you can copy the file. You can do a SQLite dump. You can dump it as SQL. Like most of the databases let you dump the SQL, or you can dump it raw wrapping as well. Often taking the SQL dump is more portable. Yeah.
So which one would be the best for
Well, as I was saying, a lot of people are doing really big stuff that tend to use MySQL. So I admit, that tends to be the strongest thing. There is, so out of the box, Postgres has some minimal support for this sort of stuff, but there's what's it called, Statistic or something like that. It's a third-party thing that's extended on Postgres. I haven't actually used it, but it's meant to be a competitor to this. But most people are using MySQL for big clusters.
There was a very interesting post on Facebook tech blog today about how they switched up InnoDB to RocksDB in the backend, and they just saved 50% of processing speed, space. So big companies are still using MySQL, right? So
yeah, a lot of them are. I just think using something where something else will work. I think it's a strong reason to use MySQL. Yeah, people are using it for the There was someone at the back.
Actually, I wanted to ask you about the data pump mechanism is being implemented.
So it's really quiet in the back.
The data pump mechanism is being implemented.
So I couldn't hear that again.
data pump.
Data pump.
Oh, data pump.
Data pump.
Data pump mechanism is being implemented.
Talking about something like pub subs sort of stuff?
Yes. Data pump mechanism for the so in Oracle we have the
Right, so replication or something like that.
Yeah.
Yeah.
How
so
is
that's,
it implemented if we are trying to implement the same type of code over here and with the database what we were using?
well, if you're just talking about replication, yeah, the databases do support stuff. You have to read them and see exactly how it works, but it tends to be with what they call the writing head log. So you have the one database and then writing
So it's
operations
just
that
file
are doing one
copy,
database.
just basic file copy, not right. You don't have a specific utility or ability to it to automate the.
I guess you could do it that way, but that's the thing. At least Postgres, for example, has an ability to write a head log replication thing, so you can just create. For a master slave setup, yeah, you can just get out of the box.
Anyone else have any questions? Well, thanks, Simon, everyone.